Our first speaker will be James McCarthy, Agassiz Professor of Biological Oceanography at Harvard. He's also been the co-chair of the IPCC, the Intergovernmental Panel on Climate Change, and he was the one who did the work in the Arctic that you saw played out in the newspapers in 2000 and 2001, showing that there was this frightening phenomenon of puddles where ice used to be. The second speaker will be Sarah Gilley, and Sarah is an oceanographer at Scripps, and she's been steadily monitoring the health of the Antarctic through satellites and buoys that they've been dropping there, and she was also physically there 10 years ago. Then we're going to have Greg Stone of the New England Aquarium, whose trips go everywhere from tropical paradise to frozen hells, or paradise as you see them. And his last trip to the Arctic in the winter of 2001, he did a 2-month trip to B15, which is that iceberg the size of Connecticut that's calving off Antarctica, and that became an important article in National Geographic. And finally, Usha Lee McFarlane, who's an environmental journalist with the Los Angeles Times, and her last trip to the Arctic was a few months ago, and she said she was near it just a few weeks ago. So with this panel, we'll get an idea of the state of the polar regions and what it might mean. Dr. McCarthy.
Thank you, Doug. I will start right into a presentation here as soon as I have the screen down, and I'll show you some slides. My task today is to talk with you about the Arctic and what I would like to do is discuss with you some of the changes that have occurred in the last few decades and longer. But the point that I'll be making is that the rates of change are much faster now than they have been in the past, and are consistent, I will suggest, with some of the information that we have about the rate of climate change globally. This is a view of the Arctic sort of pole on. You see one large block of ice here, which is Greenland. You see a pretty good sized block of ice on Ellesmere Island. And then beyond that, smaller bits of ice. Now, this little smaller bits of ice in Alaska really are a few thousand glaciers. But it's just about all that's left of what at one time, as recently as 18,000 years ago, a sheet of continental ice that covered all of this part of North America and much of northern Eurasia and northern Europe. That retreated and, of course, left behind, there was literally 2-mile high sheet of ice here 18,000 years ago. As it retreated, it left behind that rubble we call Martha's Vineyard and Long Island and places like that. This is a massive block of ice. It's maybe 10% of the fresh water on the surface of the planet right now, not groundwater, but surface water, fresh water, frozen here. And there's some indications of changes around the perimeter of Greenland, but Greenland makes its own climate. A mountain of ice like Antarctica, you will not expect to see any time in the next decades or century or so dramatic changes in the interior of Greenland. At least we'd hope the Earth would not warm to that point. However, missing ice on this graphic is the sea ice, and I'll show in a moment, which extends throughout much of this area, much of the year, and this is a more sensitive indicator of some of the changes that are occurring, as well as the glaciers. Now, there was a lot of news this summer about Hubbard Glacier in Alaska, which is the largest tidewater glacier in North America. That is, it goes right to the ocean. You see Russell Fjord here. It surged ahead and pinched off this little closure, which it did once a decade or so ago, leaving only a trickle of water through here. The Lake Russell built up, and this was a concern. But after about a month, it burst through and cleared out again. So this is very much in the news and confused people. Well, wait a minute, this glacier is advancing. I thought glaciers are retreating. Indeed, if you go to any location, you will find that not all glaciers are performing exactly the same, but 90% of them are retreating, and 10% or fewer are advancing. So, notwithstanding a bit of confusion like that, the press, you will see, the New York Times today, a big story about the glaciers in the Andes and how they are shrinking at a very alarming rate and what that means for future water prospects for many areas in the Andes. So if we go back to sea ice for a moment, here is a chart that shows, here's Greenland in this case, here's Alaska. It shows the Scandinavian Peninsula here, shows in solid white the area of the Arctic which would have been known to be permanently ice covered. That is, this in the summer, this is solid ice. There will occasionally be fractures known as leads, but basically not open water contained within this area. This is an atlas that dates back a few decades. It's put together by the CIA, of all people. And in the summer, you would have expected to find this stippled area, area that would be intermittent ice. This is serious ice. This is ice which, if you're used to thinking in feet, is 10 or 12 feet thick. This is broken up, so you could maneuver in here, but it would be very, very precarious unless you were in an icebreaker, because you get squeezed by these blocks of ice, and, well, Ernest Shackleton did that experiment for us. Then you move further out in the summer, you would see more open water, but notice, I mean, here in the Northwest Passage, you see that this is the kind of ice that would historically have kept ships from moving through here, even in the summer. And then you find in the winter, this would be intermittent ice, and ice would extend out to this thinnest layer in the winter. The trip we did a couple years ago started in Svalbard, which again in the summer would not have ice except right on the northern side, very close to land. The rest you could navigate easily. And we came to the North Pole, back to Franz Josef Land, and then did that in 2001 and 2002. This summer, I was in the Bering Sea, stopping on a number of the islands here, including a little Diomede up in this area. So this is what you find no matter where you look in the Arctic. This is the extent of summer ice, 1996, 1997, 1998. And here is what one sees from the data that can be compiled from a variety of records from 1900 to the present, is that, and these would be sealing records and records from the trading companies at Hudson Bay and communities, and you see that the ice began to fall off here a few decades ago, and at an increasingly rapid rate. And for the last 20 years, we have a higher quality data with satellite observations. But another very interesting data set, and what those data show us is that, notice this does not go to zero here, this is 10, 11, 12, 13, is that it gives us a rate at which ice is being lost, and I'll show you that in a few moments. The other very interesting data set that became available just a couple of years ago as a result of declassification of military data is the submarine data that were first available in the mid-50s. As soon as nuclear submarines existed, people couldn't resist the temptation to take them under the Arctic ice and spend a fair bit of time exploring an area that had not been available before because of the period that nuclear submarines could stay submerged. But they were always measuring the thickness of the ice. The reason being that if they got into trouble and they had to come up, they'd want to be able to come up in an area of relatively thin ice rather than relatively thick ice. And so as the ice fractures and spreads apart, sometimes it'll close up again, sometimes it will refreeze. It'll be a nice long crack. So they did a lot of mapping. They come along and find thin ice. They would take the time to map to find the orientation of that thin ice so that when they came up with their submarine, they look like this rather than like this. And so these data were archived and only retrieved. Drew Rothrock put this synthesis together. And what you find is that if you compare the period from the 50s and 60s into the 70s compared to the period in the mid to late 90s, everywhere in the Arctic, this is not a story, well, thicker some places, thinner others, everywhere in the Arctic it's thinner. And on average, it's thinner by 40 to 45%. In other words, remarkably consistent thinning. So no matter where you look, again, Greenland here, Alaska, Scandinavian Peninsula, no matter where you look in the central Arctic, and it's subdivided into various seas, you find this pattern. This is what you would have found in the early 90s, if you were late 80s, early 90s, traveling on something like this Russian icebreaker, the Amal, with its big painted ice-eating mouth here, the ice that's turned up here, you could see about the thickness of a deck up here. This is ice which is order 10 feet or so thick, and you would expect to see this continuously several hundred miles from the pole. This is what the Arctic looked like summers of 2000, 2001, within 50 miles of the pole and right up to the pole. No matter where you were at any time, you could look out and see open water. And as you can see, and I could have pointed out on that earlier atlas. Actually, let me go back to that. Just 50 miles from the North Pole is going to be a distance which is out about from this dot to that red line. So this is the North Pole. So this is in the central Arctic, but anywhere within a couple hundred miles of the North Pole, coming from this sector, these are the conditions that you would see. What else is happening? Well, the ground is thawing consistently, and Alaska is a place where this is showing up in dramatic form. So the freezing point of water in Celsius is here. What we see is at 1 meter depths, back in the 50s or 60s, it would be -3. Now at 1 meter, it's up to a point of thawing. This has enormous implication for infrastructure, for buildings, for roads, for future pipelines. There are going to be engineering problems that people have just not had to deal with in the past. So, in summary, the duration of ice cover, which I didn't mention, but in lakes and rivers is also diminished. It's about 2.5 weeks more ice-free water, lakes and rivers in the Northern Hemisphere than there were a century ago. Sea ice has lost 10 to 15% of its area, 40% of its thickness over the last 50 years. Snow cover, as well as glaciers, declining 10% for the Northern Hemisphere. Worldwide retreat, now playing glaciers last century, and widespread changes in permafrost. This, of course, isn't the end of the story, because we know the carbon dioxide record in the atmosphere from ice back 500,000 years, but look at just the last 1,000 and see this extraordinary rise. The red line are direct measurements in the last century and a half or so. And where that's taking us, of course, is if we look at this in perspective, carbon dioxide rising, here are the projections for the future. That last curve stopped here. These are the future projections for 1 century to 2100, based upon any extrapolation of current practices. And what will that mean at 2100? Well, these are degree Celsius multiplied by 2 if you're more comfortable with Fahrenheit. You see the Arctic in the next 100 years with an intermediate scenario from that last picture, warming another 6 or 8 degrees across the area we're looking at. That will have enormous implications, showing 5 different models here, which again show warming in the Arctic from the present to 2100. These are degrees C over here. Models, all the general circulation models have different ways of representing the Arctic, and you see there's a large range, but none of them go down, none of them stay flat, they all go up. This is a projection published by the Navy this past year. The Navy is now projecting that by 2030, this will be the area of summer ice in the Arctic. Here is the current area, looking rather like that atlas we saw before. Enormous implications for national security. Access through here is of great concern to the Canadians. And of course, this will tremendously shorten shipping routes through here. So some people would read that as some very good news. This is what the Navy report says. Currently suggests that seasonal sea lanes through a formerly ice-locked Arctic may appear as soon as 2015. Summertime disappearance of the ice cap as early as 2050. And of course, they need a whole new fleet now. That's what they're arguing. These are people of Little Diomede, and their lives are changing now. Every person, every adult person has seen in their lifetime dramatic changes in not only the ice, but all that means for their livelihood. And for many of them, it means their subsistence living. And of course, we know that that without ice, the polar bear would not survive as we know it today. Polar bears have reproduced in zoos, so they will probably forever be with us. But in their native habitat, they are definitely at risk with the loss of ice, the loss of cover that requires the seals to use breathing holes, which is the way the polar bear captures seals. There have been a number of cartoons in this story. Here's open water at the North Pole. Global warming seems harder and harder to deny. Polar bears and they're sunning themselves, seals playing volleyball, and of course, the cartoons have been absolutely consistent on this. In fact, I have found them quite reassuring. They don't ridicule the observer or the observation. They're self-deprecating. They ridicule us all for being part of this. We are. So I'll end there. Thank you.